is to extract them and ship them out of the country in their crude form. Of course, this does not favor us as a continent or as a country because it means that we are not getting real value for the minerals that we are endowed with. And that is why this training is very important, focusing on value chain development. Because I think the major issue is looking at this from the value chain approach. You'll be able to now understand what happens at each section of the chain, from mining to handling the crude minerals, and then to value addition, and then down to even sales and marketing. I think for me, the major importance of this conference is that we should begin to look at this value chain, because if the value chain is developed, then definitely it will impact on both the mining side and also the supply side, that is the sales side. But where the users of these minerals uh, see that there is no value added, of course, the entire system will just be as it has been. In the last month or so, I have seen the Minister of Solid Minerals launching one thing or the other. I think that is a renewed hope. If you permit me to use that word, I see some new investments coming into the country. And so for us as researchers within the country, we need to develop this value chain. And I want to encourage all of us, those of us who are interested in this sector, that little area you can make your contribution, please do so. As a university, you are probably aware that under our PASSET program, we had introduced mineral processing at the PhD level under our material science and engineering program with the Pan-African Materials Institute. Recently, we've entered into agreement with the Raw Materials Research and Development Council to add some additional programs at the master's and PhD level. Um, uh, Again, in this same area of value chain and value addition. Of course, because it's Raw Material Council, we are not just talking about minerals. We are going to be talking about value chain development for both minerals and agro commodities. This new initiative will, I believe, open up more opportunities for research, for development. So for us as academics, we are improving on what we are doing by introducing new programs that will support research, support PhD students, so that the technology component, the research component of value addition can be taken care of. But at the end of the day, what will make the country to move, or what will make everybody to move, is what happens in the industrial sector, those that are in the area of this mining value addition in the field. And I believe that the idea of this training is to improve the knowledge and skills of those who are in this sector. I can see that the topics are well crafted in such a way that the speakers will talk about different areas of the value chain. And I believe that this will make a very interesting contribution to the world of minerals processing. I want to thank all our partners who have partnered with the university in this drive. And I believe there is still more for us to do. We thrive and believe so much in partners because we believe in the spirit of the triple helix concept, where we partner with government agencies, sister universities in Nigeria and abroad, And the industrial sector, those who are actually doing the mining, doing the value addition, we should get to a point in this country where all the technology and everything that is needed in terms of knowledge and skills within the country in this particular area should be sourced inwards. And that is where we play a major role by ensuring that we can train people, we can add value, we can come up with new ideas, new projects that can support the industrial sector. Once more, I welcome you to the university and welcome you to this training program. Thank you.
Yes, we want to thank our amiable president of African University of Science and Technology, Professor Peter Azikwe Onwalu, for the welcome address. As you can see, our time is fast spent. We want to begin the training, our first training session. And I want to introduce the trainer who is going to take us further in the training, Engineer Dr. David O. Afolayan, Acting HOD of Mechanical Engineering Department at AUST, and also the head of DAV Minerals and Material Research Group, and as well the lead consultant of Afri Materials and All Consults at AUST. So please join me and welcome Dr. David Afolayan for the first training session of our 4 days program. Thank you very much. You are welcome, Dr. David.
Yeah, thank you. Please, participant, can you confirm you can see my screen? Hello, participants. Please confirm you can see my screen.
Yes, Dr. David, we can see it. I can see it.
All right. Thank you so much.
Thank you.
Yeah, so I would like to appreciate our president, the vice chancellor of AUST, African University of Science and Technology. Of course, just like I've mentioned earlier, it's so passionate about developing the mineral resources of our country, our dear country, Nigeria, because he believes that that is the way to success. And I quite agree with him. I once said this somewhere, that if any country in Africa wants to get it right, the best thing to do is invest what they have in developing the untapped resources. And in that conversation, I give an example. South Africa. South Africa today is doing well because they have invested in the mineral resources. And how do I mean? About 3-4 months ago, Mintech is just like it's just like a Southern African agency in charge of mineral resources of South Africa. About 3-4 months ago, they celebrated the 90th year of research. And I tell you what Mintech has done in Africa, not just South Africa, in Africa, is enormous. In fact, in that discussion, Ghana recently also put some money together, and they are asking Mintech to come and build something similar to Mintech in Ghana. And when we had that information, even I as a Nigerian, I was excited because having MidTech in Ghana means so much for Nigeria. And how do I mean? It is because Southern Africa is leading this example, investing all that they have in developing mineral resources. And I tell you, be it Nigeria, be it Congo, be it Cote d'Ivoire, any country in Africa, it is use the little that we have and develop the mineral resources that we have in this country. And that, for me, is the way forward. To do that, we must appreciate the value that these mineral resources have. We must begin to see that they mean so much. They carry so much value. And when we agree with that, of course, the government of African nations will not see it as too expensive to invest no matter how much money in adding value to these mineral resources. And today, we are looking at what is the role of research in content discovery. And I tell you, without research, you cannot discover the content of any mineral resources. Because it is what you see that this dirty rock, so to say, has, that will make you to put money on it. Nobody will buy gold ore so much. Nobody will put so much money on rock containing gold, because the rock in itself doesn't make sense. But the gold in the rock is what makes sense. And you cannot see with your naked eye the gold. Even if you see the gold, it can look shiny, beautiful, fine looking, as you will see the real gold. But when you do research, research will tell you there is gold in it. Research will tell you there is manganese in it. Research will tell you there is what? There is all these beautiful things in it. And that is why research is important in content discovery. And without content discovery, write it down. Without content discovery, there is no development. Because it is the value of these minerals that will make us to say, truly, when we invest in these solid minerals, development is guaranteed. And that is the crux of the discussion today. This will be the outline of my presentation. It looks like a research presentation, but I'm going to make it look like a training indeed. I'm going to be giving some instruction, which are basically sharing my own experience of what I've considered the best thing to do if we are to get it right in value addition, content discovery for development. I will emphasize basically what we are doing differently at AUST. Apparently, I've looked at so much of the work done by researchers in this country. And I will tell you, we have great scientists in Nigeria. We have great scientists in this country. Okay. Thank you so much, sir. So we have great scientists in this country, intelligent professors, and they've done good work. They've done good job. And I tell you, all that they've done can take this country from where it is to where it should be. However, to add to what I have seen them do, I'll be sharing with you some of the things that we've done differently at AUST. And I divide that into several projects. I'm going to be giving some things that I've considered to be very important for us to discover the content in the mineral, add the value it deserves to it, and put to you that if only we can do that, development is guaranteed. If we talk about mineral resources, the first thing that comes to mind is industrial raw materials. Another thing that comes to mind is the deposits, the reserve, the market, okay, and the issue of research. This that I present here today, at the center of the slides, you can see some heaps. When you look at that heaps contains many all containing minerals. In this heap that you see, there is barite in it, there is lead in it, there is nickel in it, and many other valuable minerals, rare earth metals, is in this heap that you see. But when you look at this heap, you will never see anything good in this heap. Probably, you just think they are just sand, they are just stones. Probably they are just things that are not useful. But if research or researchers come to examine these heaps, it's going to tell you in this heap, there is this valuable mineral. And typically, it's going to be very difficult for you to accept that truly, because you can't see it right there with your naked eye. Having said that, it is well established, and I'm going to be using barite as a case study for my presentation on this slide. If you look at barite is just one out of 44, or let me say over 44 solid minerals in this country. Over 44, just one of it. And if you look at the quantity of barite in Nigeria, over 21 million metric tons of barite. If we also look at the
Several perfects. So like is an agreement between the Gates border and your family. Your wife states.
Sorry about that. And so we would think about the research. I'm talking about barite, about 21 million metric tons of barite in this country. If you look at the liquid minerals, when I'm talking about liquid minerals now, I'm talking about the crude oil, basically. Over 37 billion barrels of crude oil right there as a research. These two material, or these two resources, are of industrial use anywhere in the world. Either they are given to drilling of crude oil or refining of the crude oil for different applications. Either as a PMS, a diesel, the engine oil, you can keep mentioning them. And so the market is there. Over 2 million barrels of crude oil produced per day in this country. And I tell you, there is market for it, and that's why we have that jumps of production. However, for example, President made mention of Dangote refinery, which apparently has been a boost to this Nigeria economy. But the question is, and which is basically the issues for research. It is true that barite is used for certain application, or gold is used for certain application, or nickel is used for certain application, or lithium is used for this and that application. You cannot use them in their crude form. You cannot use them to meet that need in that form. For example, like barite. Barite have to meet certain standard before you can use them. Lithium ores have to meet certain standard because before you can use them as energy minerals. Gold also have to meet certain standard before you can use them. And apart from using them, before you can take them to the international markets, they have to meet certain standards. And to meet that standard, the role of research is critical for content discovery and for value addition. In fact, it plays a significant role, even the marketing of these resources. I'll give you an example. One of the representatives of a government, I don't want to be specific. She was lamenting bitterly that a country somewhere in the Europe purchased a mineral from this country, uranium precisely, And that country will buy uranium from Nigeria at 83 cents, less than $1. And that same uranium is sold for 200 euro by that same country elsewhere. And it is really worrisome how much money we are throwing away, all because of the lack of value addition. And for me, it is not just only value addition. We don't even know the worth. The content of our minerals are not discovered. Because let's assume that the person who sells the uranium knows the worth of uranium. There is no way he will sell it 83 cents, less than $1. That means the person is selling it for just about 1,000 naira. That's so cheap. And if you have to convert 200 euros into naira, you know how much that is. And that is to tell you how much gain other countries of the world are really making on the products that they buy so cheaply from Africa. Because of our time, I will go to the next slide. Okay. As also a way of giving a very good background to what I have to say today. I'm emphasizing on what? The value. On this slide, you will see a mineral, or let me say a hull, containing, if you have to check it by color, you can see the black spots. In between the black spots, what is happening? In between the black spots, you can see some shiny parts of the black spots. You can see the white parts that looks a little bit white, and you can see some brown spots. You know, this is just an hull. And by the color, it shows that it contains possibly different mineral. For us as mineral processors, mere looking at it, we can say this is what it is. But we can only tell you just the name of the mineral. For example, the black spot, we believe it to be a lead. But the best we can say about that ore is this is a lead. But another person will ask you, of what grade is the lead? The lead here may also be of 2, 3 different grades. Similarly, the white spot, which apparently is a barite, they are also of different grade. There are 3 major grades in barites. We have the lower grade, the middle grade, and of course,
don't carry anything. Give me. Give me. I'll give you.
Participant, please try to mute yourself so that these distractions can be minimized. Now, we're talking about the what. Now, when you look at this hull that you have there, for example, someone will say this is barite, but it is not really barite. It is only a hull containing barite. Barite may be the host mineral, but it is not barite, as many probably artisans we call it in this country. And so if somebody comes to you as an artisan and said, I need a barite ore, you will take this ore and give it to him. But one thing that we have failed to realize is that in that same ore, there is lead, which we call galena, there is barite, and many other minerals. In fact, I will show you in one of the research we have done what you have in this rock, what you have in this ore. And so it is important for the artisans to know that in the ore or in the rock, there are many, many minerals. And so you cannot just sell this as barite. You cannot sell it. If you sell it as barite, you have sold this ore too cheap, because there are many things in this ore that are even much more expensive than the barite that you have in mind. And so the worth of this mineral, you will say, oh, it is heavy and it's worth, and based on that, oh, it is as high as 4.2 specific gravity, which is 4.2 gram per cm3. And then that is one of the reasons why it is considered for that application. However, just as I mentioned earlier, in that form, if you are to trade with this ore without adding any value to it, you can't have that worth, 4.2 specific gravity. And so for you to have that worth, that value, you have to remove the impurities that, in this case, lowers the specific gravity. And the reason why these impurity, which we call impurity, they are not waste. For mineral processors, we call them gang. We don't want to call them unvaluable. We don't want to call them, impurity or a waste, because lead in this barite ore has so much value. All right? And every other minerals in that ore have so much value, have its own worth. And so their worth in itself is singular. What I'm trying to say is that each of the minerals in this ore has a significant worth. For barite, what makes it considered for the application is the density. However, for the other minerals in this ore, what makes them considered is not the specific gravity, but other things. But their presence in barite will reduce the specific gravity, which is the major consideration for barite. And so, as an artisan, when you sell these ore or rock, will remain or will be seen as a material below their worth. And so value addition will not only make us to use these minerals, but largely it will help us to realize the worth of each of the mineral embedded in this ore. Another thing that is important for us to know, as professionals in this field, issues of heavy melters, issues of environmental degradation, I call it negative impact. And I tell you today, countries of the world, precisely the United States will think twice before giving a mining license to any company. The reason is because they have considered environmental impact of mining to outweigh the benefit of mining. For us in Africa, that is all that we have. If we don't use, or if we don't extract these minerals, probably we are going to remain poor. Nigeria, Cote d'Ivoire, and many other countries today that has developed reasonably by using its mineral, proceed from its mineral resources. They have considered it the last resort. Because even for us in Africa, for us to develop a critical mass, for us to train our scholars, send them to good schools, we need to trade these mineral resources. And so Africa is left to no option. We cannot do like United States and said, we are going to trade off environmental impact, trade off mineral resources availability for environmental impact. The reason is because if only we can be responsible in our mineral extractions practices, we can enhance the worth of our mineral resources and take care of our environment in a way that the so-called negative impact are minimized to the barest minimum. And so one thing that readily comes to mind to a mineral processor is good health and well-being of the people. And so it is not just for us to say, oh, we want to get the worth of the minerals. We are concerned about the life below water. What happened to the fishes? Due to the mineral extraction practices. We are careful about life on land. There is a proverb that says, what goes around comes around. We cannot be irresponsible with mineral extractions and say, let's get the wealth, let's get the gold. The danger of irresponsible mineral extraction can also be death-threatening. And so the embodiment of this training is truly content discovery, national development. These two things will remain vague, unrealistic, if the issue of responsible consumption and production of these mineral resources are not guaranteed. All right. And so the motivation for this training, the reason why we consider having this training, essentially, is this still connected? I hope you can still see my slide and you can still hear me. And so we have considered this training important for several reasons. I just showed you a hall, our rock. The slide? Okay. Sorry about that. I didn't know the slides wasn't visible again. Okay. Okay. Yeah, can you see the slide now? Yes, okay. So the reason for this training, the reason why we gathered today, and we will be talking, in the next 2 or 3 days, and of course, all our training facilitators also have this in mind. In the ore or the rock that I've showed you, the question is, what do you see in horse? What do you see in rocks? For example, miners, probably they may use color to say, oh, there is something here. And then the rock blasting commences. But in the ore, everybody will agree with me, there are impurities. But just like I've said, these are not waste. Remember that I've said that we need to separate minerals in the ore for each of them to what? To assume their worth. If we don't separate them, each of them cannot assume their rewards. They can't assume it. And so the impurities have its own worth. And so it's important that we take this to mind. The worth of each mineral embedded in the ore, it is not just a data. It is not just a piece of knowledge. It is indeed quantifiable. It is indeed sustainable. For example, there are many today who will sell some minerals without putting into perspective what is the market saying about this mineral. For instance, countries like the United States do what we call market forecasting. They can do 6 years or 5 years market forecasting. For instance, for barites have been forecasted to grow. The market will grow at 5.5% between year 2023 and year 2029. And that is to say that if the worth of barite market today is 25 billion US dollar, 25 trillion US dollar, in the next 5 years, you can actually have a guess of what it will be. And so this is what we are talking about. Just like I've said, it's not just a data. It is not just a price of what a commodity is sold for at the moment. It is apparently also prospective. What will be the worth of this mineral in the next 5 years, in the next 10 years? And if the government of our country have this also in mind, if there is this kind of forecasting, market forecasting, government of countries in sub-Saharan Africa, and of course in Africa as a whole, will be able to put in so much money in mineral development with the mind that the market has been forecasted to be a robust one in the next 2-3 years. Now, another thing you will see in the ore is the unsuitability. Okay? Rock or ore looks dirty, looks rough, looks unkempt. Our artisans, experts in the field, cannot see a ore as being unsuitable. We would expect them to see a ore. How should they see the ore? To see it as in the world, to see it in its real value. It is then they can sell this ore, or they can treat this ore with the respect that it actually deserves. What do you see the ore again? Probably you see heavy metals. And then we are scared of our health. The reason is because heavy metals are unsuitability. What do you see? The impurities. What do you see? The dirtiness of the ore. We must begin to see that above all these three things, we see the worth. We see the value that it has. All right. Next slide. So today I would like to quickly show you, the research at AUST. What we do at AUST, our president has mentioned some of the things that we're doing differently at AUST. And of course, the reason is because our experts at AUST have reviewed some of the research that were done before the commencement of research in minerals at AUST. As you all know, AUST has been recognized Yes, sorry about that. So before we had just this issue, I mentioned that AUST, have been recognized for quality research. And I'm saying this not because I'm at AUST. I think we also got this recognition from the Nigeria University Commission and many other, agencies that I know, speaking to the kind of research that we do at AUST. And the reason is because if your research at AUST is not a quality one, there is no way you can publish them. So PhD students at AUST, they don't need to be told to do quality research, because if their research is not contributing to knowledge, it's going to be difficult to even have them published. And so that's one of the things that research at AUST is known for, the quality. And this is evident with high cited research work that have emanated from this university. Our research core, essentially, this is not all, but just to mention a few, some of the focus, some of the thematic area of research at AUST. The first one I would like to mention is the research addressing issue of health. Several people have worked on developing, products to address breast cancer, targeted drug delivery, engineer materials that can serve as implants. Also, there are several of our students at AUST that have done very good job speaking to problems in the area of energy, advanced energy storage devices, essentially designed or incorporated with new materials to improve efficiency, that is the storage efficiency of these devices, energy storage efficiency of these devices. We also have the multifunctional area of research, basically people focusing on water treatment, construction, that's road construction, building construction, developing, affordable building material. People have done work on replacing the Portland cement and augmenting that with laterite calcium from animal waste, and so on and so forth. We have also done a lot of work in the area of mining and minerals. We've spent so much time looking at the worth of these minerals, the worth of these ores, through characterization, processing, and optimization. Many a times, we have achieved 87% recovery, but we not just stop there. We also develop framework that allow us to optimize, improving the outcome of research. Similarly, there is this growing area of research at AUST currently, and that's what I call biomass valorization. Scholars at AUST are beginning to make use of plants waste, converting them to useful products. We have students working on bamboo. We have had students working on plants with the aim of extracting fuel from these plants.
Good morning, madam. How are you today?
Fuels. And of course, the plant material that is
Morning.
left over, please kindly mute yourself so that we can avoid distraction as much as possible. Thank you. And so there's a lot we are doing in the area of biomass valorization. One of our PhD students was able to extract fuel from plants and succeeded in taking the waste and use it in brisket production. And there are many other fields of research. Our scholars in the Department of Applied and Theoretical Physics, Applied Mathematics, ICT, computer, are using all this knowledge and theories and practices to address real-world challenges. Some of the results of our research are all over the whole places. We have been able to provide solutions to problems. And not just solutions, affordable solutions, affordable products. We have prototypes and patents. I think this year alone, AUST has about 4 patents that have been awarded. Just, okay, let me say between the middle of last year and now, 4 patents. And I think more than 5 patents have been filed by AUST in addition to those 4 patents. And so our president is one driving this initiative, looking at the content of our research and check to see what is patentable in those research. And I tell you, in biomass valorization alone, they currently have more than 3 patents. And one of our PhD students also who just defended his thesis, had 2 patents from his work on biomass valorization. In minerals, we filed our first patent, I think about 2 weeks ago. We are also waiting for the outcome of that patent, which was filed. Other results of our work at AUST largely also depends on the human capacity development. Through research at AUST, the university has graduated hundreds of PhDs and MScs from over 21 countries in sub-Saharan Africa. And this is to tell you, apparently, this is just a summary of research at AUST. But I will tell you that AUST wouldn't have achieved this much most importantly in the area of mining, minerals, and materials engineering, without the support of the World Bank through the Pan-African Material Institute, PAMI, and most recently, through the support of course, the African governments, considering the fact that AUST is an Africa-based university, is able to put resources together to help research at AUST. But just like I've said, most recently, the World Bank also decided to support this research at AUST. And of course, the Nigerian government, other African governments puts money together, governments of South Korea, and several other international and regional corporations put resources together into an initiative that we call Regional Scholarship and Innovation Fund. It's an African-led initiative to train critical mass of scientists, agribusiness owners, and people who are driven by passion that are able to add and contribute to the growth of individual countries in Africa. And so currently, PASET is hosted in more than 15 African universities, including AUST. The PASET, through the Regional Scholarship and Innovation Fund, has partnered and is still partnering with international institutions. And that includes the Worcester Polytechnic Institute, Pennsylvania State University, and many other countries scattered in the United States and in Europe, which amounts to more than 60 institutions around the globe. Similarly, the Regional Scholarship Innovation Fund supports not just all the research, but they have a focus. The focus basically on food security and agribusiness, ICTs, including big data and artificial intelligence, climate change, energy, based solutions, which includes renewables, and of course, minerals mining and materials engineering, of which AUST is one of the Africa Host University of that thematic area. PASET, through the Regional Scholarship Innovation Fund, are able to graduate over 40 PhDs who are currently Regional Scholarship Innovation Fund, RSIF alumni. They are funded, as of today, they are currently funding more than 303 RSI PhD scholars. Funded more than 64 research and innovation grants and projects in sub-Saharan Africa countries. And of course, some of their scholars, or some of its scholars, are also at different institutions all over the world, which we refer to them as the IPRs. The Regional Scholarship Innovation Fund supports research with a blend of policy. They are interested in knowing the policy of African governments because they have believed that understanding the policy of each country in Africa is important for driving that initiative, and which is hinged on innovation and development. At AUST, as I've mentioned earlier, one of the areas of research is mining and mineral processing. And I will quickly show you what we have done or what we are doing. We are doing so much in the area of mineral prospecting, excavation, rock blasting, and characterization. One of our PhD in this area, that's Dr. Charles Komanja, who has succeeded in developing several computer-aided mining research framework. He has been able to use artificial intelligence, finite element model-based solutions. He has been able to employ the use of machine learning, multivariate regression approaches to address problems related to mining, essentially. In the area of mineral processing, we've done a lot of work in mineral characterization, comminution. And of course, there are many things that are important, which I will be showing, I will be presenting that to you in the next few slides. Why particle size distribution is important. Why mineral liberation analysis is important. Fine particle grounding. Our artisans and professionals in the field. Apparently, there is so much you can gain from collaborating with people in research. The reason is because there is a certain particle size that you have to grind your rock or your ore for you to achieve mineral recovery that you desire. If you do not grind your rock or your ore to that particle size, you can do anything. Your rate of recovery is still going to be very low. That's some of the things that we have discovered through research. I also want to tell you that particle size or particle size range of the minerals that you have crushed is important in achieving good yield and efficient mineral extraction. You might have not taken that into consideration, but I tell you, you'll be able to do better and achieve better results in your various industry if we can just share knowledge with people in research on the intricacies, or let me say the magic that is in comminution. And of course, we can also tell you how you can reduce your cost of energy in mineral processing. We've done a lot of work with our partners in the United States, Pennsylvania State University, on energy auditing in mineral processing. Also to add to that, we've done a lot of work on gravity concentration, froth flotation, basically electromagnetic separation, and we have used some of the equipment design, such as mineral jig, and of course, tabling, to separate minerals based on the differences in the specific gravity. And of course, the ability to attach to air bubbles having been modified to, align their surface properties to make that work. At AUSC as well, we are not just curious about the words, the value alone. We also do research in environmental assessment. We have published several of our works on heavy metal contamination, remediation, non-carcinogenic earth risk assessment, mine water treatment, and so on and so forth. We have looked at, and we are still looking at, issues of sustainability in mining and mineral processing. One of our PhDs, who works in one of the government agencies, work on sustainability in mining and mineral processing. And of course, he was able to look at social issues in mining with respect to, and how that affects women and child or children. One of the areas that we have just started developing in mineral processing is what I call equipment design. Now, just like I mentioned earlier, we filed a patent, our first patent in minerals engineering, mineral processing. We developed or we fabricated an equipment which can crush rocks, and specifically ores, to a particle size of 250 micron. And this equipment, which we have just filed the patent recently, is able to crush this material into powder. And so this is to encourage local fabrication of equipment and reduce our dependence on importation of mining and mineral processing equipment. The outcome of our work is also enormous. I have presented to you what AUST has done over the years with respect to the entire research. But in mineral and mining related area of research alone, we have graduated more than 7 PhDs that conducted research in mining and mineral engineering and mineral processing area of research, and several master's students as well. We have so many publications, as you can see, and you can actually see those publications in Scopus, Web of Science, Google Scholar, and presented some of these results as conference papers as well, both locally and globally. Just like I mentioned, we are curious about designing and fabricating equipment for mineral processing. We are also interested in filing more patents. We are looking forward to partnership. We currently partner with faculties at WPI, Worcester Polytechnic Institute, Pennsylvania State University, West Virginia State University, and of course, some of our local partners or indigenous partners, the Obafemi Awolowo University, Matrix Energy Group, Afri Materials and All Consorts, Total Energies, name them. And so with this support that we have, we are sure to succeed and to continue to make progress with what we do. Because of the time, I will just present to you. Because of the time, I will just present to you just some of the few things we've done, and to also tell you that we are very open to collaboration. Currently, we are working on barite ores and lithium ores. That is our focus. And so we are not doing so many things. We are just focusing on 2 minerals at AUST. We have started working on barite since 2016. We have been working on barite since 2016, and we have published several of our results. We started working on lithium about a year ago, and I tell you, we are also having so many amazing results. We are able to achieve this much because we collaborate with existing experts who have been working on these minerals. For example, like lithium, we have many of our partners in universities that have been working on lithium ores for some years now. And we have done several works together. We are still working together at the moment. Apparently, when you talk of minerals, you talk of industry. When you talk of minerals, you talk of prosperity. The reason is because of the wealth minerals has. For example, barite is so useful. Lithium today, I think, is one of the most needed minerals. Everybody wants better energy devices. And so that becomes very important. However, I also want to mention to you one of the reasons why we put this training together. And I would like to spend some few minutes on this slide. Here on the slide, I'm showing you typically what an artisan or a mineral processor will like to do. You would like to remove the dirt You would like to remove the impurities from the rock after blasting it or after crushing it, and then have something better, like what you see in C. But the question is, what you see in C still have impurities, still have what we call gang. However, we have been able to do well, just like I mentioned earlier. Most of our scientists in Nigeria, great professors, they've done a lot of work. But unfortunately, most of this work are just having been published. They seem not to contribute significantly to developing our minerals, our ores in Nigeria. And so what we are doing differently at AUST is that we are working with these local miners, local mineral processors. We started this initiative in 2017. In our first visit was to Ngwa in Guma local government, Benue State, where we were there for, I think, 1 month. The students and the professor, we had one-on-one, discussion, with miners, and we kept doing this for 4 weeks. And we realized that there is so much value research in universities can actually add to the local practices of mineral processing in Nigeria or in anywhere in Africa. And so it's important that we investigate local mining and mineral processing methods. See how fitting it is. Question it, query it. Why is it that till today, oil drilling industries in Nigeria cannot use our barites? I don't think any country will come to Africa today and said, we want a pure, or we want the highest grade mineral, because they know apparently the method that is used, or the methods that are used in adding value to these ores are either unable to provide or unable to raise the quality of these ores to specific standards that are required for industrial application. And so one of the things that we are very open to do is to collaborate with artisans and interact with them on how we can do things better. Now, the question is, we can't do anything better until we know what is the worth of these minerals contained in the rock. And before we can say this is the worth, it's important that we measure the physical, chemical, and rheological properties of this ore. For example, like lithium ores, it's important for us to know what percentage of lithium we have in the ore. We need to know the mineral. Is it spodumene? Is it kunzite? Is it lepidolite? What have you? We need to know them. And it is in our assessment of these things that makes us to sell these minerals, to respect these minerals, and to do everything possible to add value to them. Interestingly, many of the research that characterizes our university today, in Africa generally, has been looking at the suitability of, thank you, 50 minutes. Yeah, I think this is good. All right. And so before looking at the suitability, it's important that we look at the words. It is the words that makes them suitable. We cannot look at suitability. We cannot look at the specific gravity. For example, like for barite, for example. We cannot just be carried away with specific gravity. The question will be, what makes it meet that needs? What makes it worth the value, the premium that we put on it? And so for the artisans, for experts in the field, just like I've mentioned, These are the things that we need to take into consideration. And here at AUST, this is some of the things that we are doing. Like I have mentioned, and like our president also had mentioned, mineral processing, or better to say, value addition, even begins before mining. There is this thing that we call mineral prospecting. Excavation, which we call mining, then takes place. In the case of the artisanal and small-scale miners, of course, they also do some form of mining, apparently very tedious. Okay. And so when mining begins, we have the heaps, the rocks. And of course, depending on the mode of mining, we can have different sizes of the rock. And of course, we have them into heaps. And after that, that is, of course, we will say we have added value to it by bringing them out from the earth. But the question is, we cannot, just like I've said earlier, we cannot assume what the worth of the mineral or of the mineral that you have in these heaps in the figure 2. You can't assume what they are. We need to do research. We need to examine these samples using some sort of instrumental capabilities, like the use of XRD, X-ray diffraction, X-ray fluorescence, that tells us the mineral composition and the elemental composition of the ore. It is after that we can begin to come up with what the worth look like. However, we need to take it to the third stage. What I'm showing you here, apparently, is the combined efforts of what is done on the mining sites and what we do or what was done in the lab at AUST. As you can see, from stage 1 to stage 6, stage 5, all happen on the mining sites. And so the question is, when we visited the miners, mineral processors, we looked at it. What stage are you able to reach? And at what stage do we need to develop at laboratory scale? And so with the supervision of professors and research students, researchers, and owners of mining sites, we were able to develop this process. Typically, after the third stage, which is processing, that's what we call processing. But it's just like washing. That is not processing yet. It is just like you are washing it. And so the best form of processing done on the mining site that we observed with the mining site that we visited, they call it processing, but apparently it is washing. It is not processing yet. Stage 4 is what we call screening. That is one of the our contribution to what is done on the mining sites. Miners or mineral processors, or most of the mineral processors and mineral processing industry, what we have realized is that after they have done this thing that they call processing, which we call washing, because the reason is because you cannot process minerals at that particular size. Anything you are doing at a particular size above the liberation size of the mineral is just washing, not processing. The reason is because you have your desired minerals with your undesired mineral. And so nothing is done. What you have in the rock is also what you have in your so-called concentrates. And so we introduce what we call screening. Screening is not just to separate minerals into particle size. It is separating minerals manually from each other. In the minerals that you see them working with is a barite ore containing galena, containing, sphalerite, and other minerals that are there, which I will be showing you what they are. And so we introduced screening, and the miners listened to us. They separated manually barite from galena and separated each one of them into the sack. You can see something here as well. They normally do this sorting. All right? But the question is, this material that they are sorting out is the fine particle of the ore. Okay? And then they will spread it like this, and then also do some form of screening. Before now, what is done in the mining sites, after stage 3, they will jump stage 4, stage 5, and then go to stage 6. So no screening, no sorting, but they will grind or crush what they have washed, not what they have processed actually. Because from the research point of view, you can only extract mineral at their liberation size. And I'm going to explain to you if time permits today, but I doubt if time will permit me to say that. But bear in mind that before you can process mineral, you must have crushed or ground that rock to the liberation size. And one of the things that we do at AUST is liberation analysis. We are able to tell you what the liberation size of each minerals are. It is at that particle size that you can achieve maximum recovery of both the desired minerals and the undesired one. And so you crush, you grind, and at the laboratory scale, we characterize again to see how much of the impurities have been recovered. How much of the desired minerals do we have with us? And of course, in most occasions, if the particle size or if the liberation size are not attained or is not attained, there is something we call fine particles grinding, okay? Which some people call it mechano processing. We do what we call fine grinding because you have to grind the ore or the rock to the liberation size. After which we do the processing, and of course, we do the suitability assessment and the what, and then compare those results with the standards. Because of the time, let me just go ahead, just move ahead. This is some of the work we've done. And this result looks like some figures. But these results tells us what the worth of the ore or the rock is. Bear in mind that we would do this even before the processing. We do this immediately after the crushing. Before the crushing, we will do this. After the crushing, we will also do this. And then we do the mineral abrasion analysis to make us to have a feel of the worth of the material. The X-ray fluorescence tells us as well the elemental composition of that material, that rock. In the barite ore that I showed you earlier, you can see in that same rock, there is hematite there, iron 2 oxide, there is calcium oxide, there is magnesium oxide, there is aluminum oxide, silicate. Heavy metals are there, water-soluble salts are there, but you can't see all of these things with your physical eye. There is a need for you to do research and discover the contents, the worth of that minerals. For some of the materials, or some of the minerals where you need to test for the specific gravity, you can also test it and see what is the specific gravity, or what is the properties, or what is the quality, what is the worth in its crude form, and what you need to do to improve it. Because of the time, I will quickly move to project 2, where I'm hoping to round up. I've mentioned earlier that there is a need for us to begin to think about equipment design. We cannot continue to spend so much money on equipment. The issue is not even the money, but the time. Today, it can take us 1 year to get order of equipment, to receive equipment order. On this screen that you're seeing here is a mineral jig that was designed by one of our PhDs at AUST. This equipment, as you can see, that equipment looks so simple. This equipment here was able to process barite to meeting the American Petroleum Institute standard. This device that you are seeing here.
So we can't actually see it. It's on the research methods. That's where the screen is stuck at.
Oh, okay. Let me reshare, please. I guess the network is makes it slow.
Yes, we can see it right now.
Yeah. So this device was designed. Somebody may want to ask me, are you sure this was designed in Nigeria? To be honest with you, it was designed by our PhDs who was funded by the Regional Scholarship Innovation Fund. And he got some funds to travel to one of our partners at the Worcester Polytechnic Institute. And so it was at WPI that this equipment was designed, but it was designed by a USC PhD student. And what I want to tell you about this equipment is that if you look at this design stage, so this equipment you see here, if you look at figure A, that was the stage. The student was conceiving the idea. Look at the sketch. He was sketching his idea. And after he has sketched his idea, he looked for how he can put materials together. And if you look at what he used, he just made use of some PVCs, some plastics. Instead, the figure B, you can see the workshop. That was the workshop where all these things, all the tools that he used to fabricate these devices, where you can see that, you can see those tools at the background. If you look at figure C as well, you can see the tools. And the assembly, begin to assemble those things together. And then at the full scale is what you are seeing here. What he actually used is just wood, some PVC pipes, some rubber pipes, some of the things that we can also get in Nigeria. So it is not a matter of, oh, this was designed in the United States. all these parts are also available in Nigeria. So we can do the same thing in Nigeria. The fact, that's the student actually spent less than $400 for all this material. And he decided to use this material because he chose to use materials that he can also get in Nigeria so that he can, replicate the same thing when, he returns to Nigeria. So he deliberately chose this material. And most of these materials, very cheap, wood instead of iron frame. And I tell you, results of these students were published in 2 papers, cited in Web of Science, Scopus, and so on and so forth. A prototype from this, because this is just a laboratory, design. That is this, prototype from here. And of course, we are at this level now. We are putting together the prototype of this, which is going to be a bigger size of this. Not show it again. My God. Sorry for the issue with the internet. It's really very, very nasty today with internet. But we are running up soon. Internet has taken so much. I mean, all these difficulties has really affected us badly, but you have it now? Okay. Do you have it now? So on this project, we are very open to industry collaboration for scale up. We are at the level of building a prototype right now within the mechanical engineering department. We are building the prototype, which will not look exactly like this, because that's why I can show you this one, because it is after the prototype, we will then file it. So the prototype will not look exactly like this, but we are using the same principle, which it is still secret for now. But we are very open to working with industry. Move. Is this way now?
Okay now.
Huh? Is this showing now? So we are very sorry for all these distractions. So we are very open to the industry. We are very open to artisanals small scale miners or mineral processors. We are very open to large scale mineral processors on this equipment design. We can do it together. We can have a prototype well set, file the patent, and then begin with the mass production. In addition to the mineral crusher, which we call double hammer mineral grinder that we just filed a patent. We are looking forward to scale up those designs and begin to use them locally. I'm not sure the internet is going to allow us to do this. If not, I will have said this is just the video of the testing. I don't know whether it's going to work, but this is just to show the demonstration. After the equipment was completed, we put it to use, we tested it, and then we checked the pulsation because jig, the power of a mineral jig or the efficiency of a mineral jig depends on the ability to do the pulse, the water pulsation. So we recorded that, but I think the network will not allow this. But of course, this material will be shared with the participants, so you can watch that essentially. So I want to believe my time is up. Okay, so my time is up, but as you can see, I still have so much to present, but this is not this is not a defense. This is not lecture. This is not just do the whole stuff. We need to also interact from what you need to hear from experts who are even my lecturers, who are even my teachers, who knows much more than I do. It is time for us to learn from each other and, of course, to see what we are able to do. So let me stop sharing, and then we can take some questions. In fact, the first person that I saw, these are owners of mining sites, owners of mineral and mining industry in Nigeria. So that we have today great people online, and I would like you to get some comments from you. But before then, do we have questions? Do we have questions? And then after which, I would give the floor to some of our directors of mining sites who are here and who have been our partner, at AUST. And we are looking forward to doing some more work with them as well. So please, any question or contribution or comments regarding what we have shared together so far on research at AUST and why research is important to unravel the content, the worth, the value of our rock, our ores, and the minerals that they bear, so that we will begin to do everything possible, invest in value addition, because the rate of return of investment of those minerals are of a great worth. It will even exceed what is invested into it. So questions, this is time for question, comments. Any question, please? All right, let me check the charts for, okay, yeah, you can have access to this presentation. Okay, that is responded to already. Oh, sorry. Yeah, a lot of technical issues. But yeah, I can't see any question here. Okay,
yes,
so please, you have the floor. You can also raise up your hand and unmute yourself. Speak to us if you can. We'll be very glad to learn from you as well. And of course, add up to this conversation. on mineral processing value chain for content development.
Hello, sir. Can you hear me?
Can you see any hands up? Okay.
Hello.
Please unmute yourself and if your hand is up, you can unmute yourself and ask your questions or comments or contribution
Yes, sir.
as well.
You can hear me. Can you hear me? Can anyone hear me? I would love to ask a question.
Yes, we can hear you. Please go ahead.
Thank you very much. I want to thank the moderator and the thank you, Dr. Afolayan. Thank you so much. It has been a very insightful session. I've learned a lot, and I'm
Hello,
really. Yes. Can you people hear me?
Hello?
Can anybody? Oh,
Yeah,
Yeah,
we can hear
we
you
can
again.
hear you again now.
all right. Thank you. I had a contribution and a question to ask. Firstly, we are into being one of Nigeria's first indigenous lithium beneficiation plan. We really can't call it processing because what we're trying to do now is just to concentrate it to about 6 to 10% LIO. And seeing some of the machines you had shown, I'm interested in collaborating with AUST and the group of scientists who develop these machines. So I had a question. I wanted to help the machine getting upon.
Okay, sir. So what's the question?
Yes, the question is, what is the estimated time for that machine to be deployed if it is commissioned? I'm talking about the gravity separation machine, if I understood it well, and what would be its expected TPH?
Okay. So, so just like I've mentioned, currently now for the for the gravity which design, just like I've mentioned, we are currently the prototype. The time for its deployment currently is actually subject to, because for everything that we are doing at AUST, one of our research policies is that before we commercialize any product, we have to file the patent first. So, and of course, patent filing process, it's such a time that sometimes it can take 2 months, sometimes it takes more than that. Sometimes we even experience less than 2 months, depending on the content of the innovation that we are filing. So, but as per the equipment itself, it is something that we can do you can do the fabrication of the equipment. That's the equipment we can actually, the prototype that we are doing now, we're actually giving ourselves, assembling the materials together. It is something that we can do within 2 weeks after assembling the materials together. The one that we just filed the patent, it took us about 1 year and about 14 months to finish. The reason is because the time it takes to gather the material was about eight months, if not more than that, because we gather the material and then we design, and of course, at the end of the whole stuff, we needed to do some troubleshooting. We needed to change some some parts. We have to order again. And so the bulk of the time in this process is actually the time spent in ordering for the material. But the design and the fabrication itself is something that doesn't go beyond 1 month, 2 months. and we have a control over that. But the one we don't have a control over is actually the material sourcing and the patent filing stage. Because at AUST, before we take the product to the market, we have to, of course, file the patent. We patent the equipment. Patent the innovation before large scale use. So I won't be able to give a true estimate of the time frame due to the two factors that I mentioned: materials, sourcing of the materials, because some of them, it may even warrant that we require them to be imported. And so we don't seem to have a control of this time. But of course, just like I've said, the one we have done before, we spent about 8 months putting the materials together, considering that we're in this kind of a country where we have that, even to have your things shipped in, it takes a lot of effort. I believe you understand what I'm trying to say. So, but of course, in the midst of all these things, what is important is we give the push, we have the equipment, we have the patent filed. Probably when we succeeded with one equipment, we'll be able to give an estimate of the time it will take to run these 3 stages. That's, acquisition of the material, the design and the fabrication, and of course, the patent filing stage. So that will actually give us an ability to, give a good range. But for now, due to that two of the 3 processes that we don't have a control over, it will be very difficult to really state the time it will take. But if we can get the material in good time, have our patent in good time, it is something that is doable within a year. Let me just put that. Within a year, it is something that is doable within 1 year. File the patent, get the materials, do the design, and get it into the market. It's something that is doable within 1 year. All things being equal, let me put it that way. But of course, we can still have plus or minuses, considering the kind of environment where we are.
Thank you very much for the explanation. I'll be reaching out to you so we discuss.
Hello, sir.
Further. Yes, I said thank you so much for the explanation. I'll be reaching out to you so that we can discuss further on that.
Okay, what I've said is, okay. Okay, so what I've said so far is, okay, so sir, please, can you just say what you just said again?
Yes, I was saying thank you so much for the explanation. I will reach out to you so that we can talk about this further.
In progress.
Hello, sir. Yeah, sorry, we have. Okay.
Yeah, the network is quite bad. I was saying that thank you so much for the explanation. I will reach out to you so that we can talk more about this.
Okay. All right, that's good. And apparently, we have been limited as well. But I believe that industrial participation will really, and apparently, even we ourselves, we are limited without industry coming around. So also the industry are limited somehow. And thankfully, we are having this conversation, and we would like to take it up from there. Currently now, just like I've actually mentioned, things will be done quicker now, because now we have the innovator here at AUST. Like before, like the equipment wants to file the patent now, it was designed, we needed to actually give it as a contract to an engineering firm. But now we have all the experts at AUST mechanical engineering who will do the fabrication, and every other thing. So now we should be able to do the job quicker and faster than our previous experience. Thank you so much, Mr. Tim Eldon, for that, for that intervention. Any other comments from the audience? Any comments? Question? I'm surprised that there is no question. Probably I couldn't share some thought-provoking information, but of course, the way to success in mineral processing are very basic things. If only we can just look into those basic things, we will get things all sorted out. And with industry, institution, collaboration with some of our partners, in the US and some other places, I'm very sure that we can put heads together and beginning to solve the problem of our dear country in Africa, and of course, to become dependent when it comes to mineral processing equipment. I think that would be a very good one, because we've spent so much time, waiting for equipment delivery, and many things are actually just at a standstill. I think it's one of the things that we need to really look into and find a way to address it. In the absence of any question or comment, I would like to invite, so in the absence of questions, comments, I'll be handing over to the person who will continue, who will also intimate you with the event for tomorrow, so that we can start in time. Apologies for the poor internet. As I speak with you, we are using 3 different devices as internet backup, where we have to log out from one into another one. It's our challenge is peculiar, but we are hopeful that we will get around it very soon. And I believe that this is not new to all of our participants. Mr. Gaspard, thank you for joining us from Rwanda. I know several other persons also are joining us from outside Nigeria. Mr. Gaspard, you want to say, anyway, the moderator will take care of that so that we can hear from everyone who is joining us today. Thank you.
Thank you, everyone, for coming. Hope you can hear me. We are rounding up. We are closing. We want to appreciate Dr. David for the wonderful presentation. It was awesome. We have learned a lot of things from this. And of course, this is a 4-day training. This is the first day. Tomorrow we continue again. Tomorrow is day 2. We are starting at 9 a.m. prompt. From 9 a.m. to 9:30, we are going to be having the registration and other preliminary activities. The topic for tomorrow's training is energy auditing of mineral extraction for efficient and sustainable practices, making mineral extraction affordable and eco-friendly African adaptive mineral extraction. This will be taken by Dr. Samuel Olumide Ogumodimu, Assistant Professor of Energy and Mineral Engineering, Pennsylvania State University, PSU, State College, PA, USA. And also after that, there will be question and answer session, and we will also close tomorrow's on. So we are expecting everybody to be there tomorrow. Energy auditing is a very, very important aspect. We are looking at using the minimum or the barest minimum energy in mineral extraction, both processing and also the mining itself. So it's going to be a wonderful time tomorrow. We are expecting everyone to be there. Thank you, everybody, for participating. If there are no contribution, there are no questions, there are no confusion, there's nothing, then we can close at this point. I hope we can close at this point. What was the time, please? It's almost 12. Our closing time is 12. So that means fantastically, we are on time. So 1 minute and then we are done. Thank you, everyone. I don't think there are any reactions. Okay, Mr. Gaspard, Mr. Ogo, Mr. Benjamin, thank you all for coming. And we have a lot of others, a host of others, Engineer Abdurrafi, who is also okay, the director from Matrix, who is also a facilitator in this program, Mr. Akinwale Ojo, and we have seen Mr. Mohammed Sani, also Mr. Tim, thanks for your contribution, your question and all that, and your potential collaboration. Thank you very much. Mr. Oyelade, Olalekan Oyelade, thank you also for coming. We appreciate everyone. So tomorrow is another day. We'll be hoping to see you tomorrow. Thank you all for coming.